In a recent Harris survey, individuals were asked, do you believe in ghosts? Among 510 teens, those are individuals 13 to 17 years of age, 224 responded, yes, I believe in ghosts. Among 2,463 adults, 1,010 said, yes, I believe in ghosts. We're going to use randomization to judge whether there's a difference in the belief of ghosts between the two groups. So let's look at our steps here. First of all, for step 1, we have independent sampling. We randomly sampled teens and then independently randomly sampled adults. We asked, do you believe in ghosts or not? So we have a qualitative response with 2 outcomes. Either you believe in ghosts or you don't. Step 2 is to determine your null and alternative hypothesis. The null hypothesis is always a statement of no change, no effect, no difference. That would mean the proportion of teens who believe in ghosts is the same as the proportion of adults who believe in ghosts. We want to know, is there a difference between the two? Is the proportion of teens different from the proportion of adults who believe in ghosts? Now we go ahead and build our null model. We're going to use the randomization for proportion applet. So you select applets, resampling, randomization test for 2 proportions. In the original example with the traditional versus flipped classroom, we used data. Now what we're going to do is use summarized data. So our sample 1 will be our teens. Our sample 2 will be our adults. For the teens, how many of our teens believed in ghosts?
224.
224 out of the 510. And so we type 224 successes out of 510, and these are my teens. And then for my adults, I had 1,010 out of 2463. 1,010 out of 2463. These are my adults. For the problems you do in my lab, you're going to be using a fixed seed. I'm using a dynamic seed. Click compute. So here we're saying your belief in ghosts has nothing to do with whether you're a teen or an adult. If you look at this raw data here, a 0 means you don't have the characteristic, a 1 means you do. We're basically going to randomly assign adult or teen to the outcome, is the idea. Meaning whether you're an adult or a teen has nothing to do with whether you're a 0 or a 1. And then we compute the difference in sample proportions between the two. Our observed difference in sample proportions is about 0.029. So all we do here is randomly assign adult, teen to whether you believe in ghosts or not over and over and over again. So let's just do this another 5,000 times. Now here we have a 2-tailed alternative. You see that?
Mm-hmm.
And so we're interested in the difference of negative 0.029 or less and 0.029 or more. And so our p-value is the sum of those two quantities, 0.245. So for 2-tailed tests, you select both below and the above. So this guy right here is step 3. There's my p-value because it's a 2-tailed test. And then step 5 is just to state your conclusion. So I'm going to interpret the p-value, and then we'll state our conclusion. If there is no difference in the proportion of teens and proportion of adults who believe in ghosts, we would expect a difference in sample proportions as extreme or more extreme than that observed in about 25 of every 100 repetitions of this study. So we observe something that really isn't all that unusual. Therefore, there is not sufficient evidence to suggest there is a difference in the proportion of teens versus the proportion of adults who believe in ghosts. Our p-value is not low, and therefore our null does not go. Again, notice the distribution of the outcomes here is approximately bell-shaped, right? So it suggests a normal model might be worthwhile here. It's centered around 0, and there's this natural variability. The red shaded region is the proportion, or is the outcomes that were as extreme or more extreme than those observed.